Hello, and welcome to the next video in the MiGA tutorial series. In this video, we will attempt to clarify and explain the taxonomic classification results users will see after submitting their genome sequences to MiGA. The results section starts with a summary of the taxonomic classification. As discussed in previous videos, this is calculated based on ANI and AAI of the query genome against the reference genomes. MiGA then attempts to make inferences based on these obtained values and predetermined thresholds for each taxonomic rank. For instance, if a given sequence shares at least 95% ANI with a reference genome, there is a high likelihood that it should be assigned to the same species. For more divergent query sequences, AAI is used. Genome sequences are hypothesized to be from the same genus if they have an AAI above 65%. If the sequences show AAI between 45 and 65%, they are hypothesized to be from the same genera of the same family. Further information on this approach and thresholds used can be found via this information box. MiGA's p-values for each assignment to a taxonomic rank reflect the confidence for the assignment given the distribution of AAI or ANI values among all genomes grouped at the same rank. For example, all members of a species for species-level assignments, and where within this distribution, the corresponding ANI values between the query sequence and its best matching reference genome fall. That is why MiGA will not make any inferences on p-values over 0.5, as that indicates a greater possibility that the identity value obtained for the query genome lies outside of the distribution of values for the taxonomic rank in evaluation than inside of it. MiGA also provides a confidence, or p-value, that the genome is novel at a specific rank, that is essentially the inverse of the p-values of classification in the previous step. Here you see the classifications with the higher p-value from before expressing the higher confidence they do belong to novel classifications. For our sample genome, there is a high confidence that the sequence belongs to a species, genus, and family not represented by the genomes in the reference database. Below this section is an AAI table which shows AAI values for the query sequence against the closest related genomes in the database. In this example, we can see that with an AAI falling in the 45 to 65% range, MiGA was able to make confident taxonomic inferences up to the family level. Below this taxonomic level, confidence decreases dramatically, indicating that the query genome represents a novel genus. However, for query genomes that have closely related reference genomes, users will see a higher confidence taxonomic inference made even down to the species level. In this example of Salmonella enterica, the AAI percent is above 99 and a confident genus assignment was made. Closer examination of the ANI table allows the user to infer species level similarity. Analysis of the 16S ribosomal RNA gene is also offered when the gene sequence is detected as present. The thresholds on sequence similarity are listed on this slide based on the established thresholds by the Ribosomal Database Project, or RDP. To summarize, MiGA offers a variety of graphical outputs in order to help users understand their sequences and classification results. Understanding the goals and limitations of each analysis is essential to accurate interpretation. Often, confident classification can only be made at specific ranks of taxonomy and not others. MiGA's classification strength will continue to grow as more reference genomes become available, so please deposit your new genome sequences to MiGA. In the next video, we will discuss the rest of the screen and specifically quality assessment of submitted query sequences.